Alright, CNT125 Routing Protocol Lab. We just got done configuring OSPF and working with it. We're now going to take that off and put on our hybrid routing protocol, EIGRP. So I happen to be on the 4221. So config, let me get my keyboard set there, config T. We're going to say no router OSPF 2. We need to put that process number in that we configured. And we're saying the neighbor is down. We're going to turn right around and do router EIGRP, and this one we need to plug in the autonomous system number. This number is in the private range that we can use. Other ones are ones that would be registered with certain companies. So we're kind of up using like private addressing, if you will. What do we got here? 64512. There we go. 64512. And that's the autonomous system. Our routers that are going to communicate need to be using that same number. They need to be using that same number. We're going to plug the same networks in we did before, but we can drop the area 0. So we will do network 170.70.16.0 inverse mask 0, 0, 15, 255. Remember, we barred to the 16 place. We barred to the 16 place, so 1 less 15 will be my inverse. We have the 32 network, and we have the 48 network. So I'm going to do exit, exit. I'm going to do a show run. Coming down here, there is my EIGRP config. I'm going to be smart. I'm going to copy those. Control C. I will do a copy run start on my router. And I'm going to move my console over to the 2011. And I'm going to put that config over there. You can do it there. There you go. I knew you could do it, router. So I'm going to move the console over to the 2011. Enable, config T. We're going to say no router OSPF2, the process ID. We're going to turn right around and say router EIGRP. And our autonomous system number 64512. 64512. And I'm going to right click in here and paste those 3 networks in that I did on the other router. Little tricks Mr. Brown has for you. Okay, I'm going to do a show run. And I'm going to make sure that is in there. It is. Nice. Okay, so I will do a copy run start on this guy. Alright, so I took OSPF off, now I put EIGRP on. This is our hybrid routing protocol. Alright. What I'll do is give it just a minute, and I'm going to try, look at my link lights, make sure I can ping across the WAN. So I'm going to make sure my other workstation over here is awake, and it has not fallen asleep. You can do a little PC, there we go. And I'm going to try my ping across the network to my other PC. In 4810, I'm pinging away. So my network should be up and going. Again, if it's not, go to the end of the lab, troubleshooting tips, see if you can track down where something might have gone wrong. I'm now going to look at my routing table. Show IP route again. This time I should see 3 networks. And previously we saw R over here for RIP. We saw O over here for OSPF. Now we see D for EIGRP. Because EIGRP external is EX. So, okay, odd number, odd letter. But, alright, there's showing us that we're getting EIGRP. Okay, let's take a look at this table for a minute. Again, we see 16.0 directly connected on this port. We see 32.0 directly connected on this port. All makes sense. We say that we can get to the 32 or the 48 network if I go out this port to this router, which is the other router. And there's my metric. Yeah, that looks a little weird. The RIP, we understood it was one router. OSPF, we understood it was like factoring together bandwidth, so forth, to give us a cost metric. Now, with EIGRP, it actually does a calculation. There's an actual formula it uses that calculates together bandwidth, load, delay, reliability, MTU, maximum transmission unit. And the lower that number is, the better the route. Well, this is only a 100 meg link that's, really not all that fast. So it's like, okay, that's a pretty decent number. But as the bandwidth gets better on that link, that drops down. That number will drop down. So there's the EIGRP metric. Okay, it's composite metric. And then here's the administrative distance, 90. If you remember, RIP was 120, OSPF was 110. This is 90. So this the information that this gets for the routing table is a little bit better than the other two. That's why we did this one last. If you have an entirely Cisco network, it's pretty common that you might be running EIGRP on them. And I think the college routers uses EIGRP between them because they use a lot of Cisco here. So there is my routing table for EIGRP. I'm going to copy this guy, Control C. I'm going to open my notepad. I will paste that in, Control V, and I'm going to save this guy as my EIGRP routing table. Again, the only way I could get that is if my network was up and running successfully. Routing table. That's the only way I can get that. I'll save that guy. So there's my EIGRP routing table. All right, let's look at some events. Debug IP EIGRP. So debug IP EIGRP, and I think this one is summary. Let me do a quick question mark here. Yeah, summary. I think that's the only thing. Shoot MMARY. That's fine. That's good enough for what we're doing. We'll leave that on for a minute. I'm going to disconnect the cable between and then plug it back in. So let's just kind of force the issue. I'm going to disconnect the link between the two routers here. Boom. Okay. We should see some messages come in, and we do. It's letting us know that fast Ethernet port is down. We'll probably see that, hey, I've lost connection with my neighbor. And then as I plug it back in here a little bit, we'll probably see it starting to connect back up and basically add those networks back into the table that it had taken out. So if we give it a minute, it'll probably show some other messages here of pulling these the other network that it learned out of the table. And we'll plug our link back in between the two. If we give it a couple seconds, we'll probably see a note that, hey, this is coming back online. It's actually starting to talk to its neighbor. I've learned my neighbor over here. We have a new adjacency. And then eventually it'll start updating the table and plugging this back in, getting the network back in the table. In this case, our 48 network that's on the other router. It'll put that back in the table here pretty shortly. So we'll give it a second, and then we'll take a look at our routing table here and see if it has been put back in. Show IP route. And it has. It's already put that back in there. A little bit quicker than the other two. A little bit quicker than the other two. So there are some events happening, debugging my events. What I'm going to do here is do undebug all. Shut those off so it does not sit there and churn away and use our processing. Let's take a look at some Wireshark packets. So I will open up my Wireshark again, and we're going to look for some EIGRP. And I'm going to pause a second while this is running. All right, I let it run about 30 seconds to a minute here. I'll stop my capture. I'll put an EIGRP filter in. And there's a couple of EIGRP packets. We're going to see this looks very similar to the OSPF. Because there is no real events going on, so it's periodically talking to the neighbors going, hello. So I'm going to open one of those up. If I look at my Ethernet header, I'm going to see very much what I did with OSPF. It's coming from a Cisco. It's going to a multicast group, 01005E. If I look at the IP header, it's coming from a router port going to a multicast group, 224.0.0.10. And actually another little fun tidbit here if you take a look at. If I look at my Ethernet header, the destination address 01005E, that's a multicast flag. It's a multicast flag. If I look at the tail end over here, 000A, 0A, if you remember your hexadecimal conversion, A is 10. If I look down here now at my destination IP address, 224, that's the 01005E, that's multicast. This signal's multicast. If I look at the last octet over here, 10, that comes from that. Actually, those two are tied together, I should say it that way. This gets assigned, and then this gets used to reflect that that's that multicast group. That is pretty nifty stuff. It's pretty nifty stuff right there. So there is my EIGRP update. So we're seeing a lot of similarity between OSPF. We're seeing a lot of similarity. The big difference we're seeing here was that composite metric, factoring it a lot more than the other two protocols did. So we'll do a file save as here, and we will call this EIGRP packet capture. All right, and I can close that out now. All right, so there's my packet capture. All right, before we do anything else in the lab, we want to make sure we gather both of our router configs for submission. And looking down here, here's our list of files. So before you do any cleanup, make sure you get your router configs. So I'm going to go here to my 2011. I'll do a show run. I'm going to keep this hitting the space bar here until I get it all. I'm going to scroll up, make sure I get the show run command, and copy all that down. Control C. I'm going to open up my notepad. Excuse me. I think I can drop my font down a little bit now. We'll do something like that. There we go. And I will paste this in. I will do a file save as. And I think on this one I'm calling it 2011. Yeah, 6 of 2011 config. Something like that. That'll be fine. I'm going to do 2811 config. And I'm going to put EIGRP to remind me that's the config that's on there. I will save that one. And then I want to do my other router. So let me plug into the other router. Enable, show run. There we go. Scroll up a little bit. Make sure I get this one, 4221. Make sure I get it all. Control C. I'll open up a new notepad. Paste that in. I will save this as, I'll call it 4221 config. Yeah, EIGRP. So I have my two router configs now. So do a quick check. Before you clean up anything else, do a quick check. Make sure you have all of your files. So I'm going to go to my folder over here. I have my two router configs. I need to look for my RIP routing table and my RIP capture. I have them. I need to make sure I have OSPF routing table, OSPF capture, EIGRP routing table, EIGRP capture, and I should be good. The only thing left would be to add my questions in here. Add my questions in, the routing protocol lab questions, these right here. These should be pretty easy to answer after doing the lab now. Looking at RIP, significance of the source and destination IPs, looking at OSPF, EIGRP, and then the significance of source and destination IPs for OSPF and EIGRP. Make sure you add those in your submission, and then on both the routers and the switches, make sure you do an erase startup config. I can do that on both routers and both switches. That's all I need to do. I don't need to do anything else. And when I power down the rack, all the configs on there, nothing will be saved. So the next time it powers up, they'll be clean routers and ready to go. So do that, and then make sure you cable your PCs back to the college and set them for dynamic. And that should be the cleanup we need for this lab.